Hi, this is Dr. Pitarsius, Associate Professor, Department of ECE, SRM Madurai College for Engineering and Technology. I am going to teach about digital signal processing. Today we are going to see about some basics of digital signal processing. First, what is signal processing? The best example of signal processing is humans. The most advanced signal processors are done by our human brain. For example, speech and pattern recognition and speech synthesis. If you hear someone speech, our brain is searching and analyzing and synthesizing the about the person speech and identify the person name and etc. So you encounter many types of signals in various applications. For example, we know electrical signals, mechanical signals, acoustic signals, and other signals. Example of electrical signals are voltage, current, magnitude, and electric fields, and etc. The velocity, force, displacements are some of the mechanical signals examples. The acoustic signals are sound, vibration, etc. Other signals are pressure, temperature, and etc. So, normally the signals are analog in nature. They are continuous in time and amplitude. If you want to process the analog signal, we should convert the signals into digital signal using sensors and transducers, etc. So analog circuit process these signals using resistors, capacitor, inductor, amplifiers. Some of the analog signal processing examples are audio processing in FM radios and video processing in traditional TV sets. Some of the limitations of analog signal processing are accuracy, some of the major limitation. Second is limited repeatability due to tolerances, changes in environmental conditions like temperature, vibration. Another limitation is sensitivity to electrical noise. The electrical noise created by some of the electrical components is used in the circuits. Another one limitation is limited dynamic range of voltage and currents. Another one is inflexibility to changes. Another one is difficulty of implementing certain operations like non-linear operations, time varying operations in analog signal processing. The last one is difficulty of storing information. So if we want to overcome these limitations, we should go for digital signal processing. So digital signal processing, we normally represent the signals by a sequence of numbers by using sampling or analog to digital conversions. To perform processing on these numbers, the digital computer is called digital signal processing. The reconstruct analog signals from processed numbers done by reconstruction or digital to analog conversion. Here we can see the block diagram of analog to digital converter or DSP and digital to analog converter. Here the input is analog signal is given to analog to digital converter. The output of analog to digital converter is given digital signal. Then the digital signal is processed by digital signal processor. Then again the signal is converted to analog by using digital to analog converter. So some of the examples of analog to analog input and analog output is digital recording of music. Analog input and digital output is touch tone phone dialing. Digital input to analog output is text to speech. So another example. Another is digital input and digital output is compression of file on computer. Yes, some of the pros and cons of digital signal processing. First, we can see about pros. The one is accuracy. So in analog signal processing, the accuracy is difficult. So here you can get better accuracy, repeatable, sensitivity to electrical noise is minimal. Dynamic range can be controlled using floating point numbers. Flexibility can be achieved with software implementations. Non-linear and time-varying operations are easier to implement. Digital storage is cheap. In analog signal processing, digital storage is analog signal processing. Storage is difficult, but in digital signal processing, storage is very cheap. For example, if now we are using 1 TB hard disk for storage in digital data, it's a very advanced technical advancements in storage by using compression techniques. So digital information can be encrypted for security. The last one is price and performance and reduced time to market. So these are some of the pros of digital processing. The cons of digital processing are sampling causes loss of information. Analog to digital and digital to analog requires mixed signal hardware. So hardware issues, and third one is limited speed of processors. That's one of the cons. And the last one is quantization and the round of errors. It may create some issues in the data. Here we can see both analog and digital and mixed signal processing cycle. Here the continuous time signal and systems is converted to discrete time signal systems using analog to digital converter. And this is an interface system between continuous signal and discrete time signal. The analog systems, the examples are analytical techniques and analog processing are there. Digital systems, the numerical techniques and digital electronics processing techniques are used. This is the full analog to digital converter, or analog signal is converted to digital, then digital to analog. Here we can see analog input is given to analog filter. Then the output of analog filter is band limited signal. The band limited signal is given to analog to digital converter. Analog digital converter converts the analog signal to digital signal. Then this digital signal is given to digital signal processor. The output of processor is processed digital signals is given to digital to analog converter. Then and the output is given to reconstruction filter, and finally we will get the analog output. So we use reconstruction filter to avoid the aliasing for sampling. So here we see using the sample and hold circuit. The another one is process quantization. The quantization converts a continuous amplitude signal x of t into a discrete amplitude signal x and d of l. In theory, we are dealing with discrete time signals. In practice, we are dealing with digital signals. The major difference between ideal and practical conversion is that an analog digital to converter generates sample values that are known with finite precision. The ADC is the device in which both quantization and binary coding of the sampled signal take place. The b-bit quantizer can represent 2 power b different numbers. If the input's amplitude range is divided into k quantization intervals of equal with delta, that is quantization step, and the output levels are uniformly speed spaced, the resulting quantizer is called uniform. Another one is term is quantization noise. The two major types of error introduced by an analog digital converter are aliasing error and quantization error. Here we can see the signal. Um, since the quantization is a nonlinear operation, analysis of quantization error is done using statistical techniques. If there is a large number of small quantization intervals, the signal Xc of t can be assumed to be approximately linear between quantization levels. So we can use some formulas to find out the quantization error. The reconstruction, the general formula that describes a broad class of reconstruction process is given by x r of t. The small r represents the reconstruction that's equal to summation n xn into g r of t minus n capital T. The process of fitting a continuous function to a set of samples is known as interpolation. Here we can see the interpolation formula in shaded blue color. Next class we will see about the signals, what are the various signals are used in signal processing. Thank you.